Okay, hello and welcome, and thank you for giving me the possibility to talk about Bitcoin and blockchains and basically give you an introduction about this, in my view, groundbreaking technology. Since Hugo, you made such a nice introduction of myself, I can just skip that and talk longer about Bitcoin, which is a good thing. And how did it all begin? So basically in October 2008, a undefined, unknown person, or maybe a group of people named Satoshi Nakamoto, presented the Bitcoin white paper on bitcoin.org and laid out the foundations of a system that is there basically to become a financial system that doesn't need trust from intermediaries. And on January the 3rd in 2009, the first public block of the Bitcoin blockchain has been mined. And the idea that Satoshi Nakamoto laid out in the Bitcoin white paper was basically that it should be a money for the internet, for the digital age. And the reason for this was that, as you all know, in 2008 and 2009, there was the big financial crisis. And he laid out in the white paper that commerce on the internet is relying almost exclusively on financial institutions. We need that trust because otherwise there will be a lot of fraud. And this fraud can in real life be avoided by using physical currency, but in the digital realm, you can cheat basically because it's possible to double spend a transaction. So this was the first block of the so-called Genesis block of the Bitcoin blockchain, and you can see it was imprinted in the first block, the headline of the Times of January the 3rd. That's on the one hand, another sign like a timestamp to connect it to the times. And on the other hand, it's a political statement referring to the financial crisis of the time. So the big solution with Bitcoin was that it was the first time that you had a digital currency that really managed this problem to have a system that doesn't need trust. So it's a trustless system. The problem with double spending is fairly easy to explain. Imagine you have a digital file like a PDF, and you can copy that basically at a zero cost infinitely, meaning when you have an infinite number of a digital file, then it doesn't have any value anymore. And also, you can send it to different people. If it wouldn't be, if it would be able to double spend, then you could basically pay for one good 2 times. And this actually is not a feasible system, as we all know. So Bitcoin solved this problem the first time in the history of cryptocurrencies, because Bitcoin was not the first project of its kind. The first bigger cryptocurrency was founded in 1990 by David Chaum. It was called eCash or DigiCash. And David Chaum was the first one who used private and public keys for his digital currency. And the problem with DigiCash or eCash was that it was a centralized company and it failed in the end. In 1997, Adam Back came up with the Hashcash algorithm, which was basically a tool to prevent spam, to make spam very costly. And the Hashcash algorithm can be found now in the proof of work mining algorithm of Bitcoin. In 1998, around the same time, Wai presented his B-money. And he was the first one who added a distributed network to his currency. At the same time, 97, 99, Nick Szabo presented his paper on BitGold. And he was the first one who had an idea how it's possible to issue digital currency without the central bank. And he also basically invented the concept of smart contracts. And in 2008, Satoshi Nakamoto combined all these technologies and systems and added the time chain, as he called it, a digital ledger with a chronological, exact and correct order. And all that together is preventing double spending. If we take a look at the technical foundations, they are coming from different scientific fields. The first one is cryptography. That's basically also the reason why it's called cryptocurrency, because those currencies all use cryptographic functions, like the public key cryptography or hash functions for transparency and at the same time privacy. Peer-to-peer networks. The Bitcoin network is a decentralized network of equal peers, so there's no hierarchy. Every full node, which is basically a software that you can install on your laptop, on your own computer, is verifying all transactions that are done or that are coming into the blockchain that are sent from one person to each other. And those full nodes also hold identical copies of the blockchain. So at the same time, all around the world, all the full nodes have the same identical state of the blockchain. Then we have strategies from game theory, like the incentives for miners, the block reward for the miners so that they don't cheat. The proof of work mechanism is basically a puzzle that the miners have to solve. And also in the social consensus, like how are people going to behave, what are they going to do with different incentives is also a part of Bitcoin. And as I said before, the blockchain is basically just a database with all transactions in the correct order. And all that together was Bitcoin, or is Bitcoin. When we take a look at the blockchain, so that's basically just a graphic illustration. That's not really the blockchain. It's just a demo. It works like that. So you basically have a block with a certain number of transactions, and each block has its own fingerprint, its own hash, which is in the last row of this graphic. And every 10 minutes, around 10 minutes, a new block gets added to the blockchain. And it is chained together with the hash of the previous block. So in each block, you imprint the hash of the previous block. In the next block, the same thing happens, meaning that as soon as somebody wants to tamper with block number 2 in the middle, for instance, the whole blockchain is breaking apart, and every full node can see that this miner or this block has a non-valid transaction in it, and it breaks the blockchain apart. And this blockchain, this database, is stored decentralized by, I think at the moment, around 10,000 full nodes all around the world. And it carries all transactions that have ever been done on the Bitcoin blockchain since 2009. And you can imagine it a little bit like a decentralized Google Sheet, where everybody has the same set of transactions at the same time. So it's an identical copy. And through the hashing functions, it's also possible that basically a lot of data is stored and only needs a very small amount of data. That's the reason why the complete blockchain is only 326 gigabyte big. And now, what is Bitcoin mining? In the background, you can see a small mining rig. It's basically computer chips, high efficient computer chips that mine, that only do this hashing. They only calculate the hash algorithm. The first thing miners do, they validate transactions. They take a look on each transaction. Does it fulfill the network requirements, the network rules of the blockchain, of the Bitcoin network? Then they add transactions from the mempool to a block, and then they start mining. So they are solving a mathematical problem, and the fastest one who presents the correct solution is allowed to attach the block to the chain. And then every full node around the world confirms this block. And only if all full nodes confirm the block, it is added to the blockchain, to the longest chain. And the winner of the block earns this 6.25 Bitcoin award and the transaction fees of all transactions that have been put to the block. And this incentive is the block reward is halved every 4 years. And this is also the reason why there will be only 21 million Bitcoin ever, because this is a rule in the Bitcoin protocol. It is also written as a mathematical calculation, basically in the Bitcoin software. And it defines the halving every 210,000 blocks. That's about 4 years. And the end of the issuance will be reached in 2140. Then, from then on, there will be no new Bitcoins mined. So there will be no new Bitcoins coming into existence. The miners will only earn money from the transaction fees. Bitcoin is basically a public financial infrastructure. It's for the common good. You can compare it a little bit, or you can compare it to the communications protocol that the internet is using. So at the base, you have a general protocol layer, like in the internet, the TCP/IP protocol. And you can say that's basically the same the Bitcoin blockchain is. It's a cryptographic ledger on which Bitcoin is running. On top of that, we have an application layer. In the internet, if we take, for instance, the mail service, then we have the simple mail transfer protocol, SMTP. The parallel to that is the Bitcoin protocol that is describing the rules for transferring Bitcoin as the currency. On top of that, you have different applications. In email, for instance, it's Gmail or Outlook or any other email software that you use on your computer to send emails. And in Bitcoin, it's Bitcoin, the token, the coin. That's the application. And on top of that, we now have different second layer protocols. One of the biggest and the one that should enable or enables Bitcoin to be sent in very small amounts and also without congestions because of the scalability is the Lightning Network. The Lightning Network is basically pegged to the Bitcoin blockchain, and every payment on the Lightning Network is immediately settled as if it is a Bitcoin transaction. On top of that, we have another application layer with so-called labs, Lightning apps, or sometimes decentralized apps, dApps, that can be wallets or other kind of services. And this combination of these technical foundations makes Bitcoin so unique because it's permissionless, meaning everybody can join. It enables financial inclusion through this permissionlessness. It's neutral. There's nobody who says, this is a good transaction, this is a bad transaction. Every transaction is basically the same from a neutral perspective. It's transparent, which it has to be, so that the 21 million limit is never overwritten, or because it's open source and everybody can check the code. It's non-inflatable. That's what I said before with the 21 million, which makes it a store of value because you don't have money inflation in that sense, money supply inflation. It relies on the social consensus between all participants on the network. It's borderless, making it a real global money, or maybe one day currency. It's decentralized. There is no single point of failure. Nobody can exclude anyone. And it's also censorship resistant, which is also a very important part, because if we didn't have the censorship resistancy, then we wouldn't need a money like Bitcoin, because then we can use current payment systems as they now exist too. So that was it. Thank you very much for listening, and you can follow me and have fun the rest of the evening with the other keynote speakers.